Solve the equation 15x cubed minus 10x squared minus 105x equals 0 algebraically. Now you might be looking at this problem and already getting a little freaked out because all the problems that we've done before had an x squared and now we're throwing an x cubed. In fact, the problem seems almost compounded by the fact that there's an x in every single one of the terms. So what are we going to do about this problem? Okay, well, this is a nonlinear equation because not only is there an x squared, there is an x cubed. So this is certainly nonlinear. But the good news is it's already been set up to be equal to 0 because that would have been our first step to move all terms to one side, leaving a 0. That's already been done for us. So now we just need a factor. Okay, so yes, this is going to be a little bit more work because of the additional x's, but not too much more actually, as you'll see in a second. So there's actually a first step you need to do. So you should factor out a common factor, from all terms. Okay, so what does 15x cubed minus 10x squared and minus 105x all have in common? Well, we certainly see that they all have x's, so there's an x in common. But you'll also notice that all of them are divisible by 5, so I can actually divide out a 5x. And then I'm going to leave something inside. Now I'm going to use square brackets. It's kind of like bigger than a parentheses, just so it's a square bracket. And I'm going to work this out. So remember, factoring is division. So what is 15x cubed divided by 5x going to be? Well, 15 divided by 5 is a 3. And x cubed divided by x is just x squared. Good. I move on to my next term. Negative 10x squared divided by 5x. Well, negative 10 divided by 5 is minus 2. And x squared divided by x, that's just an x. And then last of all is negative 105x. So what is negative 105 divided by 5? Let's see if you can see the 10 right there. 10 divided by 5 is 2. And then 5 divided by 5 is 1. So this is just going to be a minus 21. And if you don't like doing arithmetic in your head, you can use a calculator. That's fine. So this is all equal to 0. Okay, and so now with this trinomial that's left inside the square brackets, we're going to use the AC method to factor. So I need to multiply the 3 times the negative 21. 3 times negative 21. So that is negative 63. I'm looking for factors of negative 63 that sum to negative 2. I can see negative 2. So I can do 1 and negative 63. And I can keep generating the lists, but remember, my calculator is particularly good at finding these lists. So I'll go into my calculator, go into y equals, and clear out what I've been working on in the past. I'm going to say negative 63 divided by x. So my calculator is going to divide 63 by different values and find their quotients. So let's make sure that your table set is ready and in the same place that mine is. So I'm going to go to second window. So make sure that your table start is at 0, your table step is at 1, and you still have auto. Okay, and if that's all set up correctly, go ahead and push second graph, and that'll put you in the table environment. And you can see all the pairs just sitting there. So I'm looking for the pair of numbers that will give me a sum of negative 2. So I'm just going to keep scrolling down. 3 and negative 21. So there's a pair. No. So these ones with decimals, I'm not too interested about decimals. How about 7 and negative 9? Well, 7 and negative 9 might just do it. See, 7 minus 9 is negative 2. Well, there's our pair. So I'm going to rewrite. So 5x, don't forget your square bracket. Then you have a 3x squared. And now I'll split up my b term, my negative 2x, into its two parts. So the 7x and the minus 9x. And then minus 21 equals 0. Okay. Now inside the square brackets, I'm going to factor by grouping. So I have 5x. All right. And 3x squared plus 7x. And what does 3x squared and 7x have in common? Well, 3 and 7 are both prime numbers, so I'm not going to find a common factor there. But they both have an x in common, so I can at the very least factor out an x. So this is going to just be a 3x plus 7. All right, and then in the second pair, I have a negative 9x. Well, now I'm going to pull a negative out. Okay, and what does 9 and 21 have in common? I believe that we can also factor out a 3. So pull out a 3. So negative 9x divided by negative 3 will be a positive 3x. And a negative 21 divided by a negative 3 is going to be a positive 7. Don't forget the square brackets. Okay, last step. We're going to factor out the common factor. So this term has a 3x plus 7 and 3x plus 7. So in the square brackets, you can see the 3x plus 7. And then the other pair you can see just sitting there as x minus 3. So x minus 3. Close square brackets equals 0. All right, give myself some more room here. So, all right. So the square brackets now, they were very helpful for us up here when we had a big sum going on. But now that we've broken this into its factors, you don't need the square brackets anymore. You can just say 5x times 3x plus 7 times x minus 3 equals 0. Okay, so now we're at the part that we use the zero product property. Now, in times past, remember we keep saying A times B is equal to 0 when A is equal to 0 and B is equal to 0. But what if we actually had three numbers, A times B times C equal to 0? Well, what could you say then? Well, that either A is equal to 0 or B is equal to 0, or third option, C is equal to 0. You might have any combinations of that. So, but one of them has to be 0. Well, I hope you see like this A times B times C equals 0 is pretty much the same situation that we have right here. We have 5x, a 3x plus 7, and x minus 3 equal to 0. So really what I need to do is find out when each of these individual linear terms, or excuse me, linear factors equals 0. So when does 5x equal to 0? Well, divide by 5. So you get 0 divided by 5, which I hope you remember as 0. So when x is equal to 0, or when you have 3x plus 7 equal to 0, which happens when c3x equals subtract 7, divided by 3, so negative 7 thirds. Or, third option, x minus 3 equals 0, which happens when x is equal to 3. All right, so this time I have 3 solutions. Either x is 0, or x equals negative 7 thirds, or x equals 3. Now, I was kind of having my eyes peeled for 3 solutions because this was a cubic let's see. This is a third degree polynomial because it has this to the third power. So I'm kind of looking out for. So looking for 3 zeros. Now, I don't necessarily guarantee that I get 3 zeros, but I could have maximally 3 zeros. So it doesn't surprise me at all that when it's all said and done, there were 3 solutions to these equations. There's 3 values of x for which would be true. Okay, so to rehash this. So we started off with something that looked big, daunting, and huge, but look, each of the 3 terms had something you could factor out. In this case, it was a 5x, and it left you with something very manageable, which was 3x squared minus 2x minus 21, which we could definitely tackle that one from all of our practice in the previous material. All right, so hopefully you will not find these problems too much more of a challenge.